Hey everyone, I'm going to go ahead and put this lecture online. Not going to take the time to do it in class. Going to do 3 examples, and there's your homework there. And P.S. by the way, if you have not submitted a Gmail email, then do it. You're going to find the submission form on the website. So let's start. Let's get to it. This section is all about solving rational equations. And so we will start off with this first one here. So our goal is to solve for x, and the first thing that might be a little confusing to us is that we have an x in the denominator. We want to get rid of that x in the denominator. And so what I'm going to do is I'm going to multiply both sides by the x minus 4. Because that's going to make my life a little bit easier. So let's multiply both sides by that x minus 4. And what ends up happening when we distribute, we end up with x times x minus 4, which gives us x squared minus 4x. And then we have a x minus 4 over x minus 4, which crosses off. The 0 times x minus 4 crosses off to just give us a 0. So what we're left with here at this point is x squared minus 4x plus 1 is equal to 0. And so at this point here, we have to solve for x. And looks like we are not going to be able to factor this. But what we can do is we can use the quadratic formula, or we can complete the square. Personally, I think completing the square on this one is going to be a lot easier. So I'm going to pull the 1 on the other side, and I'm going to take half of negative 4 to the power 2, which is positive 4. So add 4 to both sides. And that results in a perfect square trinomial on the left over here. So we have x minus 2 to the power 2 is equal to 3. And from here we're going to take the square root of both sides, which gives us a x minus 2 equals plus and minus the square root of 3. And then we'd add the 2 to both sides to get the x all by itself, and now we have x equals 2 plus and minus the square root of 3. And let me look back at our original equation. Looks like we won't have any problems when we substitute back in those x values. We won't have any division by 0 problems, so we're all good to go. Let's move on to the next problem. So the next problem, once again, we have a rational expression or rational equation, and we want to solve for x. The problem here is that we have these polynomials in the denominator, and that's making it really difficult for us to solve. So we want to multiply both sides by the least common multiple of our denominator, so the least common denominator. And that's going to eliminate our denominators. Okay, so what I've done here in red, I've factored the denominator on the right. That trinomial factors into the same binomials we have over on the left. And so our least common denominator is x minus 1 times x minus 3. And so we're going to multiply that to both sides in order to eliminate all of our denominators. So what I have here is I have multiplied in the least common denominator to both sides. And what this does for us is this simplifies our problem greatly, because now we can cross off all of our denominators. And we're left with something that should be pretty easy for us to solve for x. So here we have a 2x times x minus 3, we got a 2x squared minus 6x, and then plus x minus 1 equals 2. And so from here we have a 2x squared minus 5x, subtract 2 to both sides, we have a minus 3. And this, to me, looks like a classic trinomial that I've factored 1,000 times. Okay, so we're going to put the minus here and the plus here. Okay, so we solve by setting our factors equal to 0 and solving for x. And what we end up with is x equals, jumping a step here, or 2, x equals a negative 1/2 and x equals a positive 3. At this point you should say, oh, whoa, we have what's called an extraneous solution, which is the 3. We cannot use 3 as a part of our solution set, because if we were to plug that 3 back in here, we would go, oh my gosh, we have division by 0. That is not going to work. We cannot use 3 as one of our solutions because it will result in division by 0, which is not defined. So our only solution for this problem is negative 1/2. Let's move on to the next problem. Okay, once again we have a rational equation that we need to solve, and the thing that's tripping us up are the denominators. We need to get rid of those denominators, and so that means we need to multiply by the least common multiple. So let's figure out what that least common multiple is. Okay, so you can see here in red that I factored the x squared plus 2x into x times x plus 2, and we can see that each one of our denominators is made of x times x plus 2. So that is our least common multiple of our denominator, and we need to multiply by that to eliminate each one of our denominators to make a problem that's much easier to solve. So let's go ahead and distribute in the x times x plus 2. Okay, everyone, here I have distributed in the least common denominator. Oops, what am I doing there? Yikes. Distributed in the least common denominator. And my goodness, what did I do? Look at that. Darn it. Okay. So, of course, I noticed my mistakes as soon as I press play. Alright. So, here we go. We've distributed in the least common denominator to the left, and we multiply times the 0 there, and on the right we have a 0, and this makes our problem much easier. We can cross off each one of our denominators, and just results in an equation that's much easier for us to solve. So we have a x minus 3 times x plus 2, which is going to give us an x squared minus x minus 6 plus 3x plus 6 equals a 0. And we got x squared plus 2x minus 6 plus 6 crosses, and we have x squared plus 2x. We need to solve that. And wow, what do you know? If we factor out an x, we have x times x plus 2, and that gives us x equals 0 and x equals a minus 2. And this is causing problems for me, because I see that if I were to substitute back these values into the equation, we would have the division by 0 problem. So on this one here, we have no solutions at all. Even though it looks like we should have a solution, we don't. So let's talk about a couple other things, and I'll let you free. Okay, so I didn't have an example that had a distributing by a negative, so I needed to put one in there because this is one thing that drives me crazy with you guys. When you have subtraction with these types of problems, it seems like half of you guys always forget to distribute the negative. You got a negative here. So I recommend the first thing you do is just distribute that negative. Distribute the negative to both of the terms in the numerator and change your sign there. Okay? So please distribute that negative and get on with your business, all right? Please don't forget to distribute the negative. Distribute that negative. Is it sinking in yet? All right, please don't forget to distribute the negative. That's right. I love to distribute the negative.